Hello everyone, welcome to CH for us. Today we'll be reading about the mole concept for ionic compounds. We have seen atoms, we have seen molecules. Then what are these ionic compounds? Atoms are single atoms of hydrogen. It is considered as atom, oxygen, nitrogen, fluorine. These all come under atoms. Then what about the molecules? H2, hydrogen molecule, O2, F2, N2. These all are considered as molecules. These are individual molecules. They can exist independently. These atoms, they cannot exist independently. Then what is the difference between the molecules and ionic compounds? Molecules, we have a molecule of hydrogen, H2. We have a molecule of oxygen, O2. Then do we have a molecule, individual molecule of an ionic compound like NaCl? Salt, table salt. Do we have a molecule of NaCl? No. So first of all, we'll understand what are these ionic compounds. If two ions, two oppositely charged ions, for example, Na plus and Cl minus, these are oppositely charged. They get attracted towards each other and they form a bond between them. That bond is called as ionic bond. Such compounds are called as ionic compounds. And how do they form the molecule here? The ionic compounds such as NaCl, KNO3, Na2CO3, they do not form individual independent molecules. Like H2, O2, N2, F2, they do not form individual independent molecules. They exist as ions closely packed together in a 3D space. Okay. For example, in NaCl, each Na plus ions is surrounded by 6 Cl minus ions and vice versa. One NaCl is surrounded by 6 Cl minus ions. They are closely packed together in a 3D space. And one Cl minus ion is surrounded by 6 Na plus ions. This is how ionic compounds exist. So that is why we are studying the mole concept for these ionic compounds separately. And here for these ionic compounds, when we calculate the mass, we should not call it as molecular mass. We should call it as formula mass. For atoms, we call it as atomic mass. When we calculate the mass of an atom, we call it as atomic mass. And if it is expressed in grams, we call it as gram atomic mass. And for molecules, the mass when we calculate it, we'll call it as molecular mass. And if it is expressed in grams, we call it as gram molecular mass. And for ionic compounds, when we calculate the mass, we have to call it as formula mass. And when the formula mass is expressed in grams, it is called as gram formula mass. Why are we calling it formula here? Because we are using the chemical formula to calculate the mass of that ionic compound. That is the reason we are terming it as formula mass. So what is this formula mass? In cases like NaCl, KNO3, Na2CO3, formula is used to calculate the formula mass. Then how do we calculate it? It is just like the molecular mass. The formula mass is found by adding the atomic masses of the atoms present in one formula unit. NaCl. This NaCl is called as one formula unit. We'll calculate the formula mass by adding the atomic mass of sodium and the atomic mass of chlorine in its one formula unit. So what is the atomic mass of sodium? See, we have calculated here formula mass of NaCl. Atomic mass of sodium is 23 units. And the atomic mass of chlorine is 35.5. When we add them, we will be getting 58.5 units. And this is the formula mass. And when we express this formula mass in grams, 58.5 grams, this is called as gram formula mass. That's now they have asked us to calculate the formula of KNO3. So how do we calculate the formula mass? We have to add the atomic masses of the atoms present in one formula unit of the given substance. So the atomic mass of potassium is 39 plus the atomic mass of nitrogen is 14 plus the atomic mass of one oxygen atom is 16. We have 3 oxygen atoms here. So 3 into 16, which is 48. So 39 plus 14 plus 48 gives 101 units, AMU, atomic mass units. 101 atomic mass units. 101 atomic mass units or 101 units. This is the formula mass. And when we express this in grams, it is called as gram formula mass. 101 grams. Okay. Now we'll see the definition for mole of an ionic compound. We have seen the definition of mole. A mole is defined as that amount of substance whose mass is equal to the gram atomic mass if the substance is atomic, or gram molecular mass if the substance is molecular. That is defined as a mole. And that is in terms of mass. In terms of number, a mole is defined as that amount of the substance which contains Avogadro's number of atoms or Avogadro's number of molecules. If the substance is atomic, we can say Avogadro's number of atoms. If the substance is molecular, we can say Avogadro's number of molecules. That is in terms of number. And in terms of volume, a mole is defined as that amount of the substance which there in volume will be taking in terms of volume. In terms of volume, a mole is defined as that amount of gas whose volume is equal to 22.4 liters at STP. What is STP? Standard temperature pressure. Okay. What are the conditions for standard temperature pressure? Temperature is equal to 0 degrees centigrade. Pressure, it is equal to 1 atmospheric pressure. Okay, we have to take 22.7 liters. This is an exception. We have to take 22.7 liters. Okay, we have to take 22.7 liters if the temperature is equal to 0 degrees centigrade and pressure is equal to 1 bar. Okay. Now, what is the definition for mole of an ionic compound? A mole of an ionic compound is defined as that amount of the substance which has mass equal to gram formula mass. In atoms, we have seen gram atomic mass. In molecules, we have seen gram molecular mass. In ionic compounds, we have gram formula mass. Formula mass expressed in grams is called as gram formula mass, or which contains Avogadro's number of formula units. Okay. We have included in terms of mass and in terms of number here. Okay. For example, we will take 1 mole of NaCl whose formula mass is 58.5 AMU, and when it is expressed in grams, so you have to take only gram formula mass here. So when it is expressed in grams, it is 58.5 grams of NaCl. Why it is 58.5? We have seen that the sodium's atomic mass is 23. Fluorine's atomic mass is 35.5. When we add these two, we will be getting 58.5. So this is a gram formula mass, and this is in terms of mass. We have to write it in terms of number also. So it is equal to 1 mole of NaCl is equal to 6.022 into 10 to the power 23 formula units. Okay, if it is atoms, we will be writing here atoms. If it is molecules, we will write molecules. But here we are learning it in ionic compound. So we have to write formula units. 6.022 into 10 to the power 23 formula units of NaCl. This is in terms of number. Now when we'll split this term, we'll be getting 6.022 into 10 to the power 23 Na plus ions and 6.022 into 10 to the power 23 Cl minus ions. This is how we'll split it. Because in problems they'll be asking the number of Na plus ions present in one formula unit of NaCl. Then you have to write 6.022 into 10 to the power 23 Na plus ions. If they'll ask chloride ions, you have to write 6.022 into 10 to the power 23 Cl minus ions. Now we'll see another example here. It is of Na2CO3. 1 mole of Na2CO3 is equal to 106 grams of Na2CO3. How do we calculate the gram formula mass? Here they have given the gram formula mass. How do we calculate the gram formula mass? We have to add the atomic masses of the atoms present in one formula unit, which is Na2CO3. So we have two sodiums there, 2 atoms of sodium, right? 2 into 23, and 1 carbon atom, 12, and 3 oxygens, 3 into 60. So when we add all these 3 terms, we will be getting 46 plus 12 plus 48, 106. This is how we'll get the gram formula mass of Na2CO3. Now they have given 1 mole of Na2CO3 in terms of number. 6.022 into 10 to the power 23 formula units of Na2CO3. Okay, now we'll split this. How do we split it? As we have 2 atoms of sodium here, we'll be multiplying it with 2 here. 2 into 6.022 into 10 to the power 23 Na plus ions we have. Here we are writing the formula unit. The whole formula unit, one formula unit. And when we split it, we'll be writing it in terms of ions. We have 2 into 6.022 into 10 to the power 23 Na plus ions, because we have 2 here, 2 sodium atoms. And 6.022 into 10 to the power 23 CO3 2 minus ions, carbonate ions. This whole is taken as one ion. Okay. Na plus CO3 2 minus. When we do the crisscross method, we'll be getting Na2CO3 as our formula unit. So that is how we calculate formula unit, formula mass, as well as the gram formula mass for ionic compounds. Now we'll see 2 important formulae which we have to keep in mind for this mole concept. First is 1 mole of any atomic substance, or else 1 mole of an atom of any element, okay, is equal to gram atomic mass or 1 gram atom. I have already said that 1 gram atom is equal to gram atomic mass, which is equal to 6.022 into 10 to the power 23 atoms. Okay, this is a very important formula. One mole of atom is equal to gram atomic mass, which is equal to 6.022 into 10 to the power 23 atoms. Now the same formula, when we write it for molecules, this will be the formula. 1 mole of any molecule of any substance, is equal to gram molecular mass or 1 gram molecule. I have already said that 1 gram molecule is equal to gram molecular mass. Now 1 mole of any molecule is also equal to 6.022 into 10 to the power 23 molecules. This was in terms of mass, and this is in terms of number. And now we'll write it in terms of volume. This is in terms of volume. How? 1 mole of any molecule is equal to 22.4 liters at STP if the substance is gas. If the given molecule is a gas like hydrogen gas, oxygen gas, nitrogen gas, then you have to consider it in terms of volume. You have to consider mole in terms of volume, which is equal to 22.4 liters at STP, standard temperature pressure. Now we have seen about the mole concept in ionic compounds. Now we'll see different formula here. Gram atomic mass of an element is equal to mass of Avogadro's number of atoms. So you all know this formula. 1 mole of any substance, this can be atom, molecule or ionic compound, is equal to 6.022 into 10 to the power 23 atoms or molecules, okay, atoms or molecules or ionic compounds, whatever it is, which is equal to gram atomic mass if the substance is atomic, or gram molecular mass if the substance is molecular. Okay, now they have said that gram atomic mass of an element, is equal to mass of Avogadro's number of atoms. So these many atoms mass is equal to the gram atomic mass. Okay, correct. We'll take this as 1. Now they have defined the molar mass here. What is molar mass? The mass of 1 mole of any substance is called its molar mass. 1 mole of any substance, its mass is called as molar mass. So from this equation, what can we understand? That molar mass is equal to Avogadro's number of atoms or molecules or ions, which is equal to gram atomic mass or gram molecular mass. So here, molar mass of an atom, 1 mole's mass is equal to molar mass of an atom, which is equal to gram atomic mass. Yes, this is equal to this. Yes, we'll take this as 2. Now from 1 and 2, what can we say? Here we have seen that gram atomic mass and gram atomic mass is similar. So molar mass of an atom is equal to mass of Avogadro's number of atoms. Okay. Now what happened here? They have given that the molar mass by Avogadro's number is equal to absolute mass of an atom. We have seen here that molar mass is equal to Avogadro's number of atoms. Molar mass is equal to Avogadro's mass of Avogadro's number of atoms. So for one atom, what will be the mass? 1 into molar mass by Avogadro number of atoms. 1 into molar mass by Avogadro number of atoms is equal to the absolute mass of an atom. It can also be written as gram atomic mass by Avogadro's number is equal to mass of an atom of element, because molar mass is equal to gram atomic mass. Molar mass is equal to gram atomic mass. So this is our final formula. Now the next formula here is gram molecular mass of a substance. This complete it is of atom. Now this side we'll see molecules, molecular mass, gram molecular mass. Okay, molar mass of a molecule. Of molecules we'll study this side. Gram molecular mass of a substance. Gram molecular mass of a substance is equal to mass of Avogadro's number of molecules. They have said that gram molecular mass is equal to the mass of Avogadro's number of molecules. Okay, we'll take this as equation 1. Now, molar mass of a molecule. What is molar mass? The mass of 1 mole of any substance. That substance can be atomic, molecular or ionic. So, molar mass of a molecule is equal to gram molecular mass. According to this equation, we can say that the molar mass is equal to gram molecular mass. We'll take this as equation 2. Now from 1 and 2 equations, what can we understand? That molar mass of a molecule, these two are same. Okay, we'll cancel this off. So the molar mass of a molecule is equal to mass of Avogadro's number of molecules. Molar mass of a molecule is equal to mass of Avogadro's number of molecules. Then for one molecule, what will be the mass? It is equal to molar mass by Avogadro's number, which is equal to absolute mass of a molecule. It can also be written as gram molecular mass, because molar mass is equal to gram molecular mass. Gram molecular mass by Avogadro's number, which is equal to mass of a molecule. So both these formulae, see, you can interconnect here. Gram atomic mass, gram molecular mass divided by Avogadro's number, which is equal to mass of an atom. Here it is mass of a molecule. So these are the important formulae which we are going to use in the mole concept. We have 2 or 3 more formulae. We'll see it next. Formula that density is equal to mass by volume. So when we take volume here and density there, we'll be getting volume is equal to mass by density. Volume will take to the numerator and then density comes to the denominator. Okay, when we change the sides, volume is equal to mass by density. So when we write this formula for a mole, then it becomes molar volume of a liquid or solid is equal to molar mass by density of the substance. Now this is the first formula here. You have to remember. Now next, number of moles. These two formula are of number of moles. How to find the number of moles? Number of moles is equal to mass of the substance by molar mass. So when you rearrange all these terms, you can also write as mass of substance. Mass of the substance, you take molar mass to the left hand side, you will be getting number of moles into molar mass is equal to mass of the substance. And when you write number of moles is equal to number of entities by Avogadro's number. Here number of entities mean number of atoms or number of molecules. Okay. So number of entities is equal to number of moles into Avogadro's number. So this video is completely about the mole concept for ionic compounds and the other formula which we are going to use. Thank you.